Hello, welcome back. Today we're going to talk about the derivative of our inverse trig functions. Now, back in the glory days of pre-cal, we learned two notations for writing the inverse function. For example, the inverse of cosine can be written as the arc cosine and the inverse cosine. And the inverse cosine, all it does for us is it finds the angle. In other words, what angle is going to have our x values. Now, because we only want one answer, we are taught restrictions. And the reason for that, like if I said let sine of x equal 1/2, we want to find out where is sine equal to 1/2. And that's going to be, of course, pi over 6 or 5 pi over 6. But the problem is, if we want this to have an inverse up here, if this one does have an inverse, we can only have one answer. So we have to restrict our domain. So for sine, we get rid of the 5 pi over 6, and we'll talk about why we do that in just a second, and we only pick the pi over 6. So arc cosine, or anything cosine, arc secant, and cotangent, which is cosine over sine, all have the following restriction. We're going to restrict them from 0 to pi. And this guarantees us for cosine that in the first quadrant, cosine is positive, and in the second quadrant, cosine is negative. So the restriction for cosine is just going to be 0 to pi. There's our restrictions. Sine, be careful, we look at the first and the fourth quadrant. In the first quadrant, sine is positive, and in the second quadrant, sine is negative. And again, anything with sine, arc sine, arc cosecant, and arc tangent, which is sine over cosine, so the sine's on top there. Now, when we restrict arc sine, be careful, we're not going to go from pi over 2 to 3 pi over 2. So we're not going to go from pi over 2 to 3 pi over 2 because it's directional, and that's not going to give us our right quadrants. So instead, we kind of cheat a little bit. Back in pre-cal, you learned that 3 pi over 2 can be written as negative pi over 2. And so our restrictions for arc sine are going to go from negative pi over 2 to positive pi over 2. So we're looking to. So let's review again why we restrict the domains. So let's look at the cosine graph below. Notice that this is a function. It does pass the vertical line test. There's my vertical lines, right, like so. But it does not, but the inverse does not exist. In other words, it's failing what we call the horizontal line test. For example, if I draw a, let me not use red here. If I were to draw a horizontal line, we intersect in more than one spot. And that fails. So we say this fails the horizontal line test. And that just means that the inverse does not exist. So what we do, we restrict the domain to allow for the inverse to exist. Notice what happens when we restrict the domain of cosine from 0 to pi. Now, take a look here. We pass the horizontal line test. I never crossed the function more than once. But now we also pass the vertical, we passed the vertical line first, and now we're passing the horizontal line test. We never cross the function more than one time. And now this has an inverse, so therefore the inverse does exist because we passed both the vertical line test and the horizontal line test. And all this means is that when we get an answer, this is going to guarantee only one solution. And that's really what we want. Like if I say, hey, what's your name? You shouldn't give me multiple names. So let's review a little bit of pre-cal here. We want to evaluate the following without a calculator. So we want to find the arc cosine of negative root 3 over 2. This is really saying that the cosine of what angle is negative root 3 over 2. And that is just going to be, it's going to be a pi over 6. I'm sorry, pi over 6. Yep, keep getting, mess that up. Sorry about that. It's going to be a pi over 6. But the negative tells me where cosine has to be. And negative cosine has to be in quadrant 2. So what's the pi over 6 in quadrant 2? Well, that is just 5 pi over 6. And there's our answer. Likewise, where's arc sine equal to negative root 2 over 2? So we want to find out where sine of theta is negative root 2 over 2. This is going to be a pi over 4, but where is sine negative? If I go back up here, sine is negative in the fourth quadrant. And so be careful. Remember, sine is restricted to negative pi over 2. So remember, we're restricted from negative pi over 2 to pi over 2. So that becomes a negative pi over 4 because this is in quadrant 4 there. So let's take a look at some more here really quickly again. If I want to find the inverse sine of negative root 2 over 2, this is the same thing. I'm going to work the inside first. So it asks, where does the sine of theta equal to negative root 2 over 2, which we already know from part 2, so we know theta is already negative pi over 4. But now they want to know, well, what is the cosine of negative pi over 4? So and we are in quadrant, remember we're in quadrant 2, so the cosine of negative pi over 4 is just positive root 2 over 2, and there's our answer. Of course, that's one that we actually know the value for, but what if we don't? Let's take a look at number 4 here. If I try to find out where does sine of theta equal 5 over 13, theta is I don't know. But last year in pre-cal, you learned something about right triangles. You could write this as a right triangle problem. Theta, we got the cosine, sine, so it's going to be sine is the opposite over the hypotenuse. I just need to get the adjacent side, and I can use my Pythagorean theorem. I can say that adjacent side, x squared plus 25 equals 169, and I can solve that. X squared equals 144, x is equal to 12. So I know that that's just going to be 12 using my Pythagorean theorem right there. Now to get the cosine of that angle, I just take the adjacent, 12 over the hypotenuse, which is 13. So I hope you enjoyed this video. Take a look at video number 2. We'll take a look at some more examples from pre-cal, and then we'll go straight into the calculus. I'll see you then. Bye-bye.